students, I am Dr. Abhilasha Durvanshi, Department of Chemistry, Dr. Hari Singh Gaur, Central University Sagar, Madhya Pradesh. Today I am going to present a lecture of BSc 3rd semester on the unit General Idea and Examination of Insecticides, which has been jointly prepared by me and Hemlata Bhamdare, UGC JRF PhD scholar from Department of Criminology and Forensic Science. Now, let's start our discussion while taking a look at what we are going to learn today. Module 5 will discuss on instrumental examination of insecticides. In module 6 we will have some case studies, and finally in module 7 we will conclude the topic. The first technique that we can use is thin layer chromatography method. The first compound that we are going to discuss is organophosphorus insecticides, and here the conditions are: the plate is silica gel G, the thickness of the plate is 0.2 millimeters, the method used is ascending, and the travelling time is 10 minutes. The visualization is UV light at 254 micrometers, and the spraying reagent identification and comparing by RF values of unknown and control. Samples after location of a spot by any of the spraying reagents. The spraying reagents uses 10% ammonium hydroxide solution. Chromatogram is kept in oven for 5 minutes at 80 degree centigrade. After spraying the reagent, bright yellow spots appear. Responding compounds are methyl parathion, ethyl parathion, chlorothion, paroxane. The second solution that can be used is 1% silver nitrate solution, which is alkaline. The plate is exposed in UV light at 366 micrometers for 10 minutes. After spraying the reagent, black spots appear. Responding compounds are chlorinated organophosphorus insecticides like DDVP, phosphomidone. The third solution that can be used is 0.5% palladium chloride solution in 1 normal HCl. When the reagent is sprayed on the plate, yellow spots appear in the presence of thiophosphate insecticides. If no spots appear, the plate is kept in oven on 80 degree centigrade for 10 minutes. Yellow or brown spots are appeared for thiophosphate insecticides. RF value of compounds with different solvents, cyclohexane and chloroform in the ratio of 70:30 is: parathion ethyl will come at 0.69, methyl 0.61, malathion 0.31, diazinon 0.30, dimethoate 0.35, and phosphomidone will come at 0.05. Metacystox is having 0.91 retention factor. Now, when we take benzene and methanol in the ratio of 60:40, parathion ethyl will come at 0.23, methyl at 0.22, malathion 0.31, diazinon 0.20, dimethoate 0.30, and phosphomidone will come at 0.25, metacystox 0.39. Now, the next mobile phase that we are going to take is normal hexane and acetone in the ratio of 85:15. In this case, parathion ethyl will come at 0.80, methyl at 0.54, malathion 0.48, diazinon 0.40, dimethoate 0.09, and phosphomidone at 0.05, metacystox again at 0.14. Now, in case of organochloro insecticides, the plate that we are going to use is again silica gel G. The thickness is 0.2 millimeters. The method is ascending, and the travelling time is the same, 10 minutes. The visualization is still with the UV light 250 micrometers, and spraying reagent identification comparing with RF values of unknown and control. Samples after location of spots by any of the spray reagents. The reagents that can be used is, the first one is 1% ethanolic solution of silver nitrate. Second is 1% ethanolic solution of diphenylamine. The reagent 1 and 2 is sprayed and plate is exposed in UV light at 366 for 10 minutes. Silver nitrate reagent gives black spots and diphenylamine reagent gives green or slaty spots. The RF value of compounds with different solvents, petroleum ether and liquid paraffin in the ratio of 90:10 is DDT 0.76 and 0.67, BHC 0.41 and 0.60, 0.66, 0.77, 0.38, Lindane 0.66 again, Endrin 0.32, Aldrin 0.80, whereas thiodane will have 0.29 and 0.44 retention factor. Chlorodane 0.12, 0.64, 0.71, 0.76 and 0.89. Normal hexane and acetone in the ratio of 95:5 will give DDT 0.65 and 0.85, BHC 0.35 and 48, Lindane 0.52, Endrin 0.50, Aldrin 0.87, thiodane 0.30, 0.60 and 0.90. Chlorodane will come at 0.50, 0.80 and 0.90. Now, the next mobile phase that we can use is cyclohexane and liquid petroleum. 85:15 is the ratio. DDT will come at 0.31, 0.51 and 0.59. BHC 0.04, 0.14, 0.46 and 0.19. Lindane 0.19, Endrin 0.08 and Aldrin will come at 0.73. Thiodane 0.17, 0.57 and 0.77. Chlorodane 0.03, 0.20, 0.26, 0.232, 0.36, 0.48, 0.56, 0.60 and 0.60. Now, the next part is identification and quantitation of organophosphorus insecticides by GLC, which is gas liquid chromatography. The first conditions are the column is 5 meter into 0.53 mm ID, OV17, 15% phenyl siloxane and 50% methyl siloxane. Megabore column of 2 micrometers thickness. Oven temperature initial is 110 degrees centigrade. Final temperature is 290 degrees centigrade. The flow rate is 10 degrees centigrade per minute and the final temperature hold is 5 minutes. Flow rate, hydrogen is at 3.5 ml per minute. Air will flow at the rate of 100 ml per minute, nitrogen 7 ml per minute and the detector is nitrogen phosphorus detector. The second condition that can be used here is the column is 50 into 0.53 mm, OV17 50%, phenyl polysiloxane 50% and methyl siloxane. Megabore column of film thickness 2 micrometer. Oven temperature initially 110 degrees centigrade, final 270 degrees centigrade and the rate is 10 degrees centigrade per minute. Final temperature hold 5 minutes. The detector that we are using here is again nitrogen phosphorus detector and the internal center is dilithium 19.8 minutes. The third condition that we are going to use is column is SPD 308 30 m into 0.53 mm ID of film thickness micrometers, oven temperature programming 150 degrees centigrade, 0.5 minute to 230 degrees centigrade at 6 degrees centigrade per minute, holding at 230 degrees centigrade for 2 minutes, then at 245 degrees centigrade at 3 degrees centigrade per minute. The carrier gas is helium, flow rate is 8 millimeters per minute and the detector here is FPD. Condition 4, the column again here is DB17 1.5 meter into 0.53 mm ID. Column temperature program is 140 degree centigrade initial to 180 degree centigrade at 10 degree centigrade per minute, and then to 270 degree centigrade at 60 degree centigrade per minute. Carrier gas nitrogen, flow rate is 4.5 ml per minute and the detector is again FPD. Now, next is identification and quantitation of organochloroinsecticides by GLC, that is gas liquid chromatography. Gas liquid chromatography is also used for the identification of organochloro compounds in biological and non-biological matrices. Prior to the advent of electron capture detector, GLC had limited utility because of non-availability of specific detectors for the purpose and also poor sensitivity of the then existing detectors. The condition here are: column is 6 meters into 4 mm ID, glass column packed with 80 by 100 mesh chrome Q, stationary phase is 15% QF1 and 10% DC200 1:1. Carrier gas is again nitrogen, flow rate is 120 ml per minute and the injection temperature is 225 degree centigrade. The column temperature 200 degree centigrade. The detector is electron capture detector, concentric type tritium source. Sample and their relative retention times are aldrin at 1 minute, alpha BHC 0.46 minute, beta BHC 0.60 minutes, gamma BHC 0.68, chlordane 1.72 minutes, PP DDT 3.28 minutes, dialdrin 2.22 minutes, endrin 2.55 minutes, endosulfan 1.89 minutes, heptachlor 0.81 minutes, calthane dicofol 1.31 minutes, methoxychlor 0.51, 3.23 and 4.8 minutes, toxaphene 1.70, 3.03, 3.66 and 4.70 minutes. Condition of mass spectrometry of organophosphorus insecticides. Ion source temperature is 200 degree centigrade. The electron volts here are 17 electron volts. Column is 3 feet 3%, OV 17. Initial temperature 1 minute hold at 200 degree centigrade. Final temperature 10 minutes hold at 300 degree centigrade and the rate is 20 degree centigrade per minute. Now, here we are going to take a case of pesticide poisoning, where we can find a number of cases of pesticide poisoning at the website that is given here, which is http://vekaconalthacinic.co.nz/resources/case/suicide pesticides. The patient here is a 4-year-old boy who was admitted to Middlemore with symptoms similar to severe Parkinson's disease, that is unable to swallow, persistent headache, fatigue and joint pain. He was unable to sit up without support, had lost muscle control and couldn't feed himself. He was unable to ride his bike and couldn't talk clearly. His pupils were permanently dilated and hadn't been small for many months. He also had very dark circles around his eyes and he could wake during the night screaming. Middlemore staff asked many questions about his ancestors and it was suggested by department that he may have Wilkins disease. There were no questions asked about his living conditions or surroundings. Staff felt it was likely to be a virus that our son has picked up. Asked also, we wouldn't asked if we had taken patient or any long aeroplane trips overseas. Patient had been to Disneyland in December 1998 and became ill after that. Passengers on long trips to and from New Zealand and exposed to the insecticides diphenanthrin, which is used to spray the aeroplanes which can attack the nervous system of some people. After 3 days at Middlemore, they were unable to find the cause of his problem, so they sent him to Starfish Hospital for Children. There he was under the care of doctor. She also contributed to the line of thinking that it was a virus somewhat similar to meningitis. Patients left the hospital with no confirmed diagnosis, but began a long series of visits to the occupational therapists at Starship. During visits to doctor, he came little progress. He still could not ride his bike, continued to fail over and to sleep for unusually long period during the day. He was not able to start school when he turned 5. Patient continued to display moody behavior, had poor balance, poor reflexes and had few fine motor skills. So they took him to another medical practitioner who diagnosed him with both diphenanthrin poisoning and malathion organophosphate poisoning. This meant he didn't had a double hit of pesticide poisoning. Patient had had numerous blood tests done by local doctors, and these tests had all shown the symptoms of pesticide poisoning. The treatment doctor reviewed these blood tests and they showed that patient's bone had stopped growing, believing to be due to pesticides poisoning. The treating doctor put him on a course of treatment, and within 1 month he started to improve rapidly for the first time in a year. So here we will conclude by saying that exposure to insecticides either during development, production or use causes adverse effect on human health. These effects are not always related to immediate and apparent injuries, but can take even years to appear. Although the general population is exposed to these compounds, farmers are in a high risk group and therefore require biomonitoring studies to evaluate acute and chronic diseases caused by exposure to pesticides. The amount of damage can be indicative of the need for continuous biomonitoring. Farmers occupationally exposed to various mixtures of insecticides using a battery of tests of genotoxicity, on the other hand, illustrates the need to implement general guidelines to minimize or prevent exposure. With all this information, here we come to the end of today's lecture. Do keep in mind what we discussed today. It's time for you all to do some self-study. This is Dr. Abhilasha Durgvanshi signing off. If you want to learn more and enhance your knowledge, you may log on to our website for MCQs, quizzes, LORs at www.cec.nic.in. Till then, goodbye.